Gas loss, presented by the group Copper-2 Telluride, also known as the Team CuTe. In this video, we will explain the following laws: the Boyle's, Charles, Gay-Lussac's combined gas and ideal gas law.
Boyle's Law. British chemist Robert Boyle, born on 1627 and died on 1691.
He found out through his experiment that gas volume decreased as pressure was increased. Boyle is largely regarded today as the first modern chemist, and therefore one of the founders of modern chemistry, and one of the pioneers of modern experimental scientific method. Boyle's law states that for a given mass of gas at constant temperature, the volume is inversely proportional to the pressure.
Boyle's equation. P1 V1 is equal to P2 V2, where P1 initial pressure, V1 initial volume, P2 final pressure, V2 final volume.
Gas. Given. First volume, 6 liters. First pressure, 1.01 atmospheric pressure. Second volume, 3 liters. Required. What is the final pressure?
Analysis. P2 is equal to P1 multiplied by V1 divided by V2.
Solution. P2 is equal to 1.01 atmospheric pressure times 6 liters divided by 3 liters is equal to 6.06 atmospheric pressure divided by 3.0 liters is equal to 2.02 atmospheric pressure. Breathing. This situation can be explained by Boyle's law concept. When you inhale, the muscle inside your lung increases that makes it expand more, which decreases the amount of pressure exerted inside the lungs. When you exhale, the muscle inside your lungs relaxes, which eventually increases the amount of pressure. This shows the inverse relationship of volume and pressure in Boyle's law that is reflected in the situation.
A syringe is a medical equipment that is used to insert or withdraw fluids. When the plunger is pushed down, the volume of liquid reduces, thereby increasing the pressure. Similarly, on the pulling up the plunger, the volume is increased and the pressure is reduced. Hence, the working of a syringe depends on the Boyle's law.
Charles' law. Jacques Charles, a French physicist and balloonist, summarized the relationship between temperature and volume of gas. He developed Charles' law concerning the thermal expansion of gases. Charles' law states that the volume of an ideal gas at constant pressure is directly proportional to the absolute temperature, which means that the volume of gas increases as its temperature increases and it decreases as its temperature decreases. Charles' law is expressed by the equation V sub 1 divided by T sub 1 is equals to V sub 2 divided by T sub 2, where V sub 1 is the initial volume, T sub 1 is the initial temperature, V sub 2 is the final volume, and T sub 2 is the final temperature. Here, we have a real-life application of Charles' law. We can have the helium balloon as an example. Helium balloon, when placed in a cold room or place, we could notice that it crumbles, but when placed in a warm room, it goes back to its original shape. Why does this happen? This happens because the temperature in a cold room is low, thus the volume decreases, and the temperature in a warm room is high, thus the volume increases. Here we have another real-life application of Charles' law that can be found in the kitchen. For example, we have baking. The substance we commonly use in baking is yeast. This makes our bread dough fluffy because this substance is known for releasing carbon dioxide bubbles. This expand further due to high temperature. The expansion with an increased temperature operates as a leavening agent that causes bakery products to be fluffy.
Gay-Lussac's law. Joseph-Louis Gay-Lussac is a French chemist who studied and discovered the relationship between temperature and pressure of a gas at a constant volume, in which he proposed the Gay-Lussac's law, which states that for a given mass of a gas at a constant volume, the pressure is directly proportional to the temperature. In a mathematical expression, we have P sub 1 over T sub 1 is equals to P sub 2 over T sub 2, where P sub 1 is the initial pressure, T sub 1 is the initial temperature, P sub 2 is the final pressure, and T sub 2 is the final temperature. Sample problem. The helium tank has a pressure of 650 torr at 25 degrees Celsius, What will be the pressure if the temperature was raised to 75 degrees Celsius? Given initial pressure is equals to 650 torr, initial temperature is equals to 25 degrees Celsius or 298 in Kelvin, and the final temperature is 75 degrees Celsius or 348 Kelvin. Required: the final pressure. Analysis: final pressure is equals to initial pressure multiplied by the final temperature divided by the initial temperature. Solution: 650 torr multiplied by 348 Kelvin divided by 298 Kelvin is equals to 760 torr. Real-life application: the pressure cooker. When the temperature increases, the molecules will gain higher kinetic energy and will collide more frequently with the sides of the pressure cooker and on the food, thus increasing the pressure on the food. Hence, the food will be cooked faster.
Another real-life application is the tire pressure. Due to high speed, the friction between the tire and the road surface is also high. Thus, high amount of heat is being generated, which is increasing its temperature. When the temperature increases, the molecules inside the tire will gain higher kinetic energy and will collide more frequently within the tire.
Combined gas law. Combining Boyle's law, Charles' law, and Gay-Lussac's law will result in an expression that shows a relationship between volume of gas, pressure, and temperature. In 1834, French physicist Benoit Paul Émile Clapeyron combined the old gas laws into one single law, which was called combined gas law. For a given mass of gas, the volume is inversely proportional to pressure and directly proportional to absolute temperature. The formula of combined gas law is P1 times V1 over T1 is equals to P2 times V2 over T2. It states that the ratio of the product of pressure and volume and the absolute temperature of a gas is equals to a constant. Here is an example of a real-life application of combined gas law. It shows that as the pressure increases, the volume decreases because they are inversely proportional to each other. This is also an example of real-life application of the combined gas law. The moon has less temperature, that's why when a balloon is brought there, it will expand in volume. But what about temperature? Let's say that it has the time when the moon faces the sun because it rotates every 27 days. The hot temperature contributes to the expanding of the balloon.
Ideal gas law. The ideal gas law is the combination of Boyle's law, Charles' law, and Avogadro's law. It describes the physical behavior of an ideal gas in terms of pressure, temperature, volume, and amount. An ideal gas is a theoretical gas whose randomly moving molecules do not interact except when they collide elastically, that is, when their collisions do not result in the loss of energy. The ideal gas law was given by Benoit Paul Émile Clapeyron. He summed up the laws given by Jacques Charles, Robert Boyle, Guillaume Montons, and Amadeo Avogadro to come up with the ideal gas law. However, this law has some variable limitations. The ideal gas law states that 1 mole of an ideal gas occupies a volume of 22.4 liters at standard temperature and volume. Then, pressure times volume divided by temperature is equals to constant, and this relationship is expressed as pressure times volume equals the number of moles times the molar gas constant multiplied to the absolute temperature. The equation of state may also be written as like this. Some of the real-life applications in where we use the ideal gas law is, for example, in airbags. Ideal gas laws are used for the working of airbags in vehicles. When airbags are deployed, they are quickly filled with different gases that inflate them. Also, in order to create containers to hold gases, the ideal gas law is used by engineers in order to figure out what volume of a container needs to be built. That's all, and I hope you have learned about the ideal gas law.